Hello, everyone. Welcome to our first event of 2023. Really glad to have you here. Today, we're going to be talking to someone really special all the way from Chile. But just before we do that, a little reminder that the session will last about 45 minutes, and there will be a recording afterwards of the session. If you have any questions, please feel free to put them on the box on the right-hand side, and we'll be answering them at the end. So I wanted to introduce you to Juan Pablo Cardenas. He is joining us from Temuco in southern Chile. He's an academic and a civil engineer working at the Universidad de la Frontera in Chile. And he has been leading the Sustainable Construction Group CS4 over there. He'll be talking to us about his work with WikiHouse Skylark in Chile, and also is going to show us a couple of prototypes he's in the process of building. So without further ado, Juan Pablo, welcome.
Okay, hi everyone. I'm very glad to be here. So thank you, Mel, for inviting me to share about our progress in WikiHouse. Okay, to begin with, I want to show you about our location. Chile is a very long country with different climatic conditions, influenced mainly by the latitude and by the variation of the altitude from the coast to the Andes mountain. This generates 9 thermal zones used for regulation. Here, as a general context, we have several problems associated with the residential sector, such as the housing shortage, the rising cost of construction materials, and the problem similar to other countries with energy poverty, which must be combined with new energy efficiency standards and some agreements that the country has made regarding to net zero and carbon neutrality. So our proposed solution in this context is our approach has been to move towards industrialization by making use of digital manufacturing, but with a focus on low environmental impact systems and materials. Using our experience in the development of insulating or insulation materials with low environmental impact, and the use of vernacular construction techniques, but in a context of digitalization of construction 4.0, you know, sustainable construction 4.0. That is the mix of these two great or big concepts. So our first steps, a little over a year ago, we buy a generic CNC router, and our first experience with WikiHouse was a section of the grant system that we modified to achieve or comply to U-value of passive house standard. This was in the context of the Santiago Icebox Challenge in 2021. Here you can see the pictures, the module, the blocks, and we use this module and a real scale for a student and show what is this mix of these big concepts. We found the grain system very interesting. However, we found that it didn't make good use of the plywood boards, leaving a lot of waste. For this reason, we began to experiment with the development of a system that will make the best use of the plywood board. In addition, due to cost issues, we try to mix or combine OSB and plywood boards. Everything was working very well, but the joints were an issue that we needed to study in more detail. At that point, I went back to the WikiHouse workspace in Slack, and I discovered Skylark. This was in April of 2021. So we got the first wall, and we paused our development to start with Skylark. In parallel, we made the first scale model of a prototype of a small house to study each of the parts of the system and study the joints. That was our principal problem in the other system. So we needed to know how this kind of joints works in the Skylark system. We quickly established a workflow using hydrothermal performance and design tools such as AutoCAD, NC Viewer to review the code of the NC for the machine, Fusion, SketchUp, and Rhino. And we start to looking for funding to make our first prototype. The funding we got did not allow us to make the whole prototype, so we simplified and made only the first part as a tiny house. In original, we want to build an office, but finally we turned the project to a tiny house that could eventually grow in a second stage with a second floor. So this was our prototype, and I will show you the details of this first prototype with Skylark in Chile. Okay, our project include the use of natural fibers as a thermal insulation and the use of clay plaster in the interior, at least in some of the blocks. Once the hydrothermal behavior was checked, we start to manufacture the blocks. Here, I want to highlight the importance of the company Egon Lautaro that became our partner and is who now provide us with plywood of very good quality. The first in Latin America to use a bioadhesive, and best of all, its factory is located only 40 kilometers from our city, so it's a very local material, so it's very good for the sustainability that we want. In this way, we improve the quality of the parts and the performance in the manufacturing stage, because we use only one provider of the plywood, so it's a very good quality, and we know the difference in the manufacturing stage. Okay, here you can see some picture of the location. As you can see, it's located in a small backyard, typical of local homes here. And also some pictures of the process. Since we only made the first part of the prototype, we made a terrace that can later be removed to make the second floor. In addition to documenting the process, we work around the prototype in undergrad and grad classes. Here, for example, you can see in the picture a passive house class visit. And I have two short videos of the construction process. Mel, if you can help me to show, yeah, thank you. This is the first short video in the middle of the stage of building. And let me pause this. And the second video is when we complete the all walls. We made some change. For example, for windows, I'm going to explain a detail for windows and put another orientation the walls to a kind of solution for the windows size. Okay. I would like to explain briefly three modifications we have made. Since we decide not to use end and corner blocks, we modified a part of the wall to join at the corners. You can see that in the first picture. And we also generate some T pieces to restrain the edge blocks, because we have to join the wall, this wall, with the floor directly, not with the end blocks. So we put a T piece here and restrain this movement. And on side, we replace the windows block by a horizontal arrangement of the walls blocks to generate windows in the space in the four blocks. In addition, this will be the blocks where we will finish with a clay plaster, all the blocks horizontal in the project. Here, here you can see how the window is looking with a frame also made of plywood. Okay, next steps will be the insulation by blowing method. The thermal insulation which will be made of natural fibers by blowing techniques, similar to cellulose blowing metal. Um, anyway, for those who do not know the process, I have a video, a short video here. Here we have a short video where you can see the process. The important thing in that with this technique is that we can reach the optimum densities for the proper use of this type of insulation made from agricultural fibers and residual fibers. So you can see in the video that the force of the air in the blowing method let us reach density around 100 kilograms per cubic meter. Okay. And other next step is to put in or install the clay plaster for interior finish. So we have already done the test for the clay plaster and expect to install them in the next weeks along with the installation of the interior plasterboard in the other wall and ceiling blocks. Finally, I want to show some other activities or other projects in which we have worked. The first was in the context of the Moda Vitar competition. We were not winners, fortunately, but you can see the versatility of the system. Here, our proposal was a one-story social housing that could be extended to a second floor. It was designed for the northern part of the country, in the desert. That is the name, Casa del Desierto. And with the energy efficiency strategies we use, we achieved the highest standard in the energy rating for homes in Chile. I have another slide with the details. So it was very interesting how the architects works with the system. And in this project, our material for installation was recycled clothes material because this is a big problem in the desert of Chile. I have another activity that I think it was very interesting. This activity we did was a workshop with 30 children's kids between 10 and 12 years old, where we built a model, Casa del Desierto, the last project, and showed them the process of cutting with CNC laser and CNC router. This was maybe 2 weeks ago, and it was very, very interesting to see the reaction of the kids. And the last one is another project. Is one that has just started. It is our first project in Skylark 200. it is already in the manufacturing process, and we hope to have the chassis assembled by the end of February. So maybe I can show more of this project in our YouTube channels or in other activity. Okay, finally, I would like to mention and thanks our team that has made all this work possible. And thank you for your attention. I hope you have been able to understand our progress. And Mel, I'm finished. I want to hear some question maybe. You are mute, Mel.
Sorry. Thank you so much. That was a lot of information, and we have many questions coming through. We actually have a couple of architects from Chile, one architect and one civil engineer from Chile. So I will start with Javiera, who is, you should be able to see the question there. Have you performed structural tests on the elements?
Yeah, maybe you can answer one part of the question, because this is a very good. Sorry, my son. It's a very good thing of WikiHouse, because WikiHouse have a lot of tests of a structural system. In Chile, we are looking for funding because we need to do the test in Chile too. But we have a lot of background in the study that WikiHouse has in the website, so you can find a lot of information and some publication about that.
Yeah, that's right. And we're going to be launching a new engineering guide this spring, European springtime, so in the next couple of months. So we will be linking all the engineering testing information in a bit of a clearer way than we do at the minute. But yeah, everything is currently on the website. It will just be a bit easier to find soon. We have another question here. Have you been able to measure the sound transmission rate of the insulation?
Of the insulation? No, we will test the sound transmission, but we hope to have good results, because we are using uh, um, a thermal insulation that has is a lot of fibers, straw fibers, but we have a very good density. We are talking about 100 kilograms per cube meters. So I hope to have good results, but we need to study in next. I hope this year.
Thank you. I have another question about the CNC router. Which one do you use?
Yeah, we use a generic CNC router. China, made in China, is a very cheap router, but works very good. Maybe if you write me an email or something, I can give you the technical specification and the cost here in Chile.
Or perhaps you can add it to the community. We've got a community on a WikiHouse community on Discourse,
Okay.
so you're able to find information there as well. We've got another question asking, do you have a repository for a tiny house you can share?
We start a kind of cloud repository, but we didn't have enough time to update all the information, but we have this task as a plan. We can share, for example, some modifications and the scale modification in CNC. You have to do some modification for the width of the MDF, you know. So we have all this work done, and we can share. Um, but we need to to find the time for to do it.
Yeah, fair enough. Fair enough. You've been really busy. I know. You've been doing so much work this last few months with the prototypes. And I have another question coming about the insulation. This is from Douglas, so I'll just show it there. Where do you source the insulation, and what machine do you use to blow it inside the walls?
Yeah, we use Germany made machine. X-Flock is the brand of the machine. Is normally used for cellulose insulation by blowing and by projection. Um, and we are using a mix of two residual fibers, one from the pine forest and other half of the pine residual forest and straw fibers.
That's great. Thank you for the answer. Another one is, are the modules available as BIM parametric objects for general architectural design?
We work or try to work with Revit, for example, but I think I don't know. This is for maybe a deep discussion, but for us um, is quick to work with SketchUp or Rhino, and then just work with the AutoCAD DXF files for putting the Fusion for generate the CNC code, the NC code. Um, Revit or other BIM tool, um, I think it's not a big advantage in the use of this kind of tool. We manage a kind of BIM concept, but only with Excel. I don't know the you know the software of I don't know, the planilla. Excel
You mean
software.
Excel as in MS
Yeah,
Office Excel? Yeah, yeah.
yeah, because we can do it. Sorry, because in this Excel file we have the number of the blocks and the time of the blocks, the cost of the blocks, the footprint. So we have all the building information in a table, and it's very fast because when you finish the model, you only put the quantity of the blocks, and you have all the information.
Yeah,
But
yeah,
you
that makes
can you
sense.
can do it in BIM software too.
Yeah, and I was going to say, if you've got any more questions about the BIM, if you have the big question is bigger, I guess what I'm trying to say, we can perhaps have a thread in the community later about that if you guys wanna do that separately. We've got another question from Douglas. What router bits do you use to cut the plywood?
Yeah, we will start with the general bits, but we have problem because in 10 boards we have to change the bits. So then we find another provider with carbide bits, compression bits of 8 millimeters, and it was a good solution for us because we can cut maybe 50 boards with one bits. This is our solution. I know there are very good bits, but we need to import from United States. It's a little bit um, um, it's a little bit the cost is highest, but you have to have more time. We are
Yeah.
cutting all days.
Yeah, no, fair enough. Could you tell us a little bit more about your clay plaster? You showed an image earlier.
Sorry about them.
The clay plaster, I'm just gonna go back to it.
Okay.
That
Yeah,
for the interior finish.
yeah, it's a normal mix of clay, straw, and sand. We did a kind of array to to discover the best proportions. Um, but it's very normal things. Maybe the modification that we have to do is to put in the I have my my wall here. Um, we are using in the walls that we put in horizontal orientation. So we with the waste of the different cuts, we put here pieces of this plywood to have a velocity, or yeah, and then put the plaster, the clay plaster here. But it's very simple method.
Yeah, it looks so interesting because you were talking at the beginning about mixing digital fabrication with more vernacular techniques. You said, I think that's a word that
Yeah,
you use. So you're trying to bring them both together, aren't you?
yeah. It's a kind of here. I don't know the name in English, but we we work with quincha. Quincha is a very vernacular system, and this is quite similar, but in the context of the digitalization of the construction.
And talking about just going back to the beginning of the presentation, you were talking about 9 different thermal zones in Chile because it's such a
Yeah.
long country. And you showed us a house, a concept house for the desert, and your prototypes have been in a different kind of climate because you're in the south. Is that right?
Yeah, yeah. Yeah, we made maybe I can share the link because in the last PRIA we show a work related with this. We work with optimization, multi-objective optimization for different climatic zones. Um, and yes, you can increase or decrease the width of the solution, but when you want to go to net zero or a very big standard, you have to use over 200. So it's not an advantage to use a low width. Um, so we propose for Casa del Desierto, Skylark, normal Skylark 2. And because in the desert, this was in around 3,000 meters, so it's very, how do you say, clima exigente. Help me.
Yeah, it's a very it's a climate that's very just has very high requirements. I guess that's what you're trying to
Yeah,
say.
yeah,
Yeah,
yeah, very
yeah.
hard to, because you have a lot of sun gains in the day, during the day, but in the night you have very low temperatures too.
Hmm, hmm. And where you are just now, where you build the prototypes, what is the climate that they're like? You're not as high as there as 3,000, are you?
No, no. In Temuco,
Hmm.
in Temuco city is yeah, in Chile is of the night climate zone. This is around the 7 is not the hard climate zone, but we have to use a lot of insulation because all people use wood burning for heating. So we have a very big problem of um, uh, particulate atmospheric pollution.
Yeah, yeah. There's a question from Stephen here. Is there a tension between designing for low cost versus designing for low environmental impact?
Uh, yes, maybe if you can go to the commercial solutions, I think is very clear. But when you try to use this kind of materials, for example, we are using residual fibers. We are trying to use techniques like blowing that is very fast to put all the insulation in the modules. Um, so you can reduce the cost in times in not quality cost, and this reduce of cost you can put in, for example, more insulation. So we are in the very competitive cost of the square meter. We are not have the we are don't have the final cost of this prototype, but we are in the range of the normal building, but with a very good behavior.
That's brilliant. That's really good. I look forward to hearing about once you put all your numbers together. If you want to share that with us later, because it would be really interesting to find out. I think there's a question from Javier about this slide that we're on just now, about the clay plaster. Is it about increasing the thermal insulation? Does that help?
Yeah. We were looking for a system where, because when we work with normal timber structures, it's difficult to grow 5 or 6 inch, for example, of wood. So we were looking for a system that we can increase the width of the insulation with no linear cost.
Mhm.
For example, in the WikiHouse, if you analyze the system, when you decrease the width, it's not very important because you have these two sorry, these two parts. So when you try to decrease the width, it's not the most important part of the complete wall. So yeah, from our point of view, we were looking for a system that we can put a lot of insulation, and then you can go to net zero or other highest behavior system.
Yeah, that makes sense. There's actually another question on insulation from Vincent. How do you deal with the blow-in insulation for small spaces in the WikiHouse system?
I think the question is about the spaces. For example, okay, we are using membranes, exterior and interior, because one of the things of the aerothermal behavior of the wall is that since you have two layers of plywood, you have to use for our climatic conditions, we have to use a vapor barrier. So we use a layer uh, inside and outside, and we can blow in the insulation next.
Thanks for that. I have another question around your plans. We briefly mentioned some structural testing. Is that what the next step is for Skylark in Chile?
Yeah, a lot of things. I am moving from one university to other in March. So my next plans are to work with robot arm during this year, and we are looking for funding to do the testing in Chile, fire behavior, structural testing, and maybe another like a sound behavior, other test to use this system as a normal system in Chile.
That's exciting. And just one final question, because we're about to run out of time. Did you say that your wood is only coming from 40 kilometers away? Is that where the pine is from?
No, the pine is around the it's in forests around the this region, maybe 200 kilometers, but the factory, all the process are in 40 kilometers of our city.
Yeah, that's brilliant. That's super impressive that you found something so close in such a massive country. Yeah, so I think this is the end of the questions for now. And I just wanted to say thank you so much for, I'm just going to go back to your last slide. Thank you so much for this. You are an active member of our community. So again, if any other questions, you can either put them at the bottom of this once the recording goes live, which will be in a couple of minutes, or you can put your questions to Juan Pablo in the community. We'll be happy to answer them. And I just wanted to say, again, thank you for joining us. Thank you for all your work, and have a great holiday, because I know you're about to go on your summer holidays. So have a great time, and we'll speak when you're back in March.
Okay, perfect. Thank you.
Thank you. Thanks, everyone. See you later. Bye.
Yeah.